The delegates, please occupy your seats. And today's session is chaired by Dr. K. Ramakrishna Reddy sir. ಇದಾಕ್ ಮಾಡಿ. And also postgraduate programs. Is an inspired teacher. And many of the students were placed in very good positions. He served in different capacities as HOD of Chemistry, PG Coordinator, and IQAC Coordinator, Purchase Committee Coordinator, Research Advisory Committee Coordinator, UGC Expert Committee member in NEP, and also SEP Model Curriculum Preparation. In October 2020, Government Science College was elevated to university, Rupatunga University by RUSA. Sir played a key role in the process of elevation a college to a university level. He served as a first register evaluation at Rupatunga University, Bangalore, till he took charge as Joint Director. Dr. Reddy sir was recognized guide for PhD program. He guided two students in their PhD program. He has completed one major research project funded by UGC New Delhi and also one KFIST level project from Vision Group on Science and Technology, Government of Karnataka. He has published over 32 research papers in national and also international peer-reviewed journals, 3 books and 2 patents to his credit. He has organized more than 20 workshops, seminars, lecture programs, and also as Indian Academy of Science, and also gave more than 45 invited talks. With this brief introduction about Dr. Ramakrishna Reddy sir, welcome you sir for chairing this session. And please introduce today's
Good afternoon to all of you. Namaskara. It's already 2 o'clock. It's 1 o'clock. I don't want to take much of the time. I thank KSTA for inviting me to chair this session. And I'm very happy to inform you that KSTA is conducting this kind of seminars. Even last year on climate change, they conducted in the month of November. This year on the groundwater. And if you look at that climate change and groundwater, that means the burning issues they are attending. Therefore, 1 month back, I received to my office, I received a letter from KSTA that you should inform to all your degree colleges in your region. Therefore, I sent a brochure to all my degree colleges. Now I have to think how many students from different government colleges have attended. And really, it's a big opportunity for entire the participants, both for the students and the teaching faculty, to know the issues in the groundwater parameters and all those things. And I'm very happy to introduce Dwarakish. He's a professor from Department of Applied Mechanics and Hydraulics, NIT Surathkal, and he's obtained his education PhD from Institute of Remote Sensing, Anna University, Chennai, MTech from NIE Mysore University, BTech from NIE Mysore University. He has a lot of experience. He started his career in 1990 as a site engineer. Now he is the professor in Department of Applied Hydraulics. Because being a professor, he has membership in many academic bodies, professional bodies. To name few, Indian Society of Remote Sensing, Indian Society of Hydraulics, Indian Society of Geomatics, Indian Society of Technical Education, and so on. He has experience in teaching both graduate and postgraduate level at NIT Surathkal. And he completed a plenty of research projects. To name few, modeling of suspended sediment concentration of Mangalore coast, management of tidal inlets along west coast of India. And he has, being the faculty in NIT Surathkal, he guided many students for the projects both in undergraduate and also master's program. And he also helped in getting placements to many activities. Now I request Dr. Dwarakish sir to give the online talk on the topic that is given by KSTA. Sir, you are welcome to this session. Please go ahead, sir. Thank you, sir.
Thank you very much, sir, for introducing me to the audience. Sir, my slides are visible. First one.
Yes, sir.
Good afternoon, everybody. Respected chairman, distinguished delegates, and my dear friends, student friends. First of all, I would like to thank KSTA for giving me the opportunity to talk about ICZMP for Dakshina Kannada coast, that too in the name of geoinformatics. Sorry, I could not come and make the presentation in front of you all over there because of hectic schedule in the form of PG, PhD, and UG. Yesterday, JOSA results were announced, and I am taking care of that for the institute admission category and all. In view of this, sorry once again, and to begin with, the name of the talk is Integrated Coastal Zone Management for Plan for Dakshina Kannada Coast. So, overview of my presentation includes specific introduction in the form of remote sensing, ICZMP, coastal processes, and also specific issues for Indian coast, how exactly it is erosion is taking place, and mitigation measures. And in the form of case study, I have selected undivided Dakshina Kannada coast to develop integrated coastal zone management plan. The talk is for about 50 to 55 minutes. To begin with, this is the basic definition available for remote sensing. It is the science and art of obtaining information about object, area, phenomena through the analysis of data acquired by a device. When you say this is the definition, there are three important points. Number one is object. The object may be a building, tankers, or anything available on that surface. Area may be water bodies, forest cover, cultivated land. The phenomenon, it is all related to natural phenomenon, that is in the form of forest fire, floods, oil slick, earthquake, drought, erosion, etc. The last important word in the definition is device. Device is nothing but a sensor, It is like collecting the information, and that information may be in the form of active or passive. In the case of passive sensor, the sensors will be utilizing somebody's energy to illuminate the object and then collect the information. Whereas in the case of active sensors, they have their own source of energy to illuminate the object and then collect the information. Just to give the examples on the lighter side for remote sensing, we all looking at the view graph without touching. That is number one. Maybe without going to kitchen, we can tell that what mummy or wife is preparing for the breakfast. If you are nearer to pickles or sweet, definitely we know what is going to happen. That is in the form of tongue. And if you go nearer to the temperature or any fire and all, definitely we feel rise in temperature. And the last one is backscattered energy. This indicates that only for our convenience, complete remote sensing activities are classified into three divisions. Number one is optical remote sensing, thermal remote sensing, and then last one is microwave remote sensing. Please note that this is only for our convenience. Depending on our application, it is possible to go deeper into the classifications. Coastal processes, we know that the coastline itself is the triple interface of water, land, and air. On the beach, lot many economical activities will be taking place. That is in the form of recreation or mineral identification, buffer zone identification, or economic developmental activities. The coast represents the meeting point between the land and sea, and there are three main processes which are operating on the coast. Number one is erosion of the land, or in this case sand, transportation of the sand, as well as deposition of the sand. So based on this, it is possible for us to identify the location which is giving a sand for transportation, that is the source, and the place the same sand is deposited, that is nothing but sink. So source and sinks, it is also in the name of erosion as well as deposition. When the sediment is moving along the beach, definitely waves plays a major role. Assume that the wave crest is at an angle of say 30 degrees with respect to the beach. This component can be resolved into two components. Number one is perpendicular component, another one is parallel component. The component which is parallel to the coast is very, very important for sediment movement from one point to the another point. The point at which it starts eroding or taking the sediment for the movement, that is nothing but the source. Where it is depositing, that is nothing but sink. So this indicates that source and sink is mainly related to sediment moving along the beach. If the beach width and also the coastal zone is around 400 meters from the shoreline, that is nothing but the beach drift area or littoral drift. Within this area, only sediment will be moving from point to point. This is one of the photographs exactly replicating the angle of attack from the waves on the beach. These are all some of the photographs. This is from Sasitlu coast, and this is from our college area, NATK beach. And this is during fair weather season or non-monsoon season. Definitely the sediment which was taken by the waves during the high wave activities, mainly during monsoon season, that will be coming back and slowly deposited on the beach. This indicates that dynamic nature is already observed from the wave activity itself. This is again during southwest monsoon season, because wave activity is very, very high. The maximum wave height so far recorded is 5.4 meters. It is not exactly the slope we will be getting all along the west coast of India. Excuse me. There are series of beaches and also beach berms will be available. These beach berms will be created mainly because of the high wave activities. Maybe during the southwest monsoon, temporary mitigation measures will be taken place, and this is one among them. Since the wave activity will be more, mainly during southwest monsoon season, whatever we take the temporary measures, immediately that will be taken away by the waves like this, because they will not be having any toe protection, and it is only top down construction. It is not from bottom to top construction. Wherever rocky outcrop is there, this is the rocky outcrop nearer to NATK beach, we have the lighthouse over here. See, the beach itself is having the protection in the form of outcrops. Whenever it is like this, definitely whenever the sediment is moving from say north to south, definitely some deposition will be taking place. These are all some of the other photographs. And this is seawall at Sositlu, erosion along Maravante beach, and this is one of the important location we have to protect, because on either side of this particular road network, we have on one side sea or other side Kolluru river. And this is coastal erosion, that too in Udupi coast. And if we are having natural protection, that too in the form of vegetation, we need not have to worry about erosion as well as deposition. These are all the breakwaters, sea walls constructed by using natural armor stones. Even after construction of sea wall, there may be during the southwest monsoon high wave activity. Just to protect the dwelling houses over here, we have the sandbag protection. This is again temporary in nature. Causes of coastal erosion. You can classify them into natural as well as man-made. In the case of natural, we have sea level rise, storm waves, wind and wave surge activities, sorting of beach sediment, etc. On the other hand, we have the man-made activities in the form of interception of littoral drift, concentration of wave activities, that too in the form of wave energy concentration, change in natural coastal protection, sand mining. These are all in general. If you consider the causes of coastal erosion along Karnataka coast, we can include these 8 parameters. Number 1 is geological factors. This is mainly because of neotectonic activities. Tidal range along west coast of India, that too related to Karnataka coast, we have 1.6 meter tidal range. Offshore relief, that is bathymetry, we have the berm bathymetry over here. Sea level changes, this is also minimum because we have the Mulki-Pulicat axis. Mulki is north of our college area around 8 kilometers. Pulicat is north of Chennai. Along that particular line, the land itself is rising upward. When the land itself is rising upward, we will be having relative sea level fall. Interception of littoral drift, that is mainly because of the breakwater. Maybe in future slide we will come to know that these breakwaters are also not affecting the coastal configuration over here. Sand mining, it is there, but it is negligible. River mouth changes, it is nominal in nature, that too during southwest monsoon. Out of these 8 parameters, the only one parameter, that is direct wave action, this is one of the important parameter which is responsible for coastal erosion along Karnataka coast. So we have 5,716 kilometers of coastline with 9 maritime states. Each and every state will be having lot of activities that will be controlled by Ministry of Environment, Forest, and also National Coastal Zone Management Authority. Under National Coastal Zone Management Authority, we are also having State Coastal Zone Management Authority. Related to Karnataka, we have Karnataka State Coastal Zone Management Authority. So in all these activities, they will be simply monitoring coastal regulation zone and also other activities within these 3 zones, that is CRZ 1, 2, 3. If you take the actual activities along the coast, Gujarat coast is mainly related to mangroves activities, settlement related to Maharashtra, tourism for Goa, coastal erosion for Karnataka and Kerala, sediment and sediment dynamics, that too for Tamil Nadu coast, cyclone and flood for Andhra Pradesh, Orissa as well as West Bengal coast will be identified in the name of biodiversity. So with these few words, we'll start the case study, that is ICZMP for undivided Dakshina Kannada coast. The main objectives for this is number 1 is CRZ mapping, identification of vulnerable areas using Coastal Vulnerability Index. This is one of the important index developed by GORDNIC. It is modified in our institute. Factors responsible for land use, land cover changes, that too in the form of industrialization as well as growth of population. Development of digital elevation model, just to identify the submergence areas. and finally to identify suitable sites for coastal tourism. This is the study area starting from Talapadi in the south. This is the starting point of Karnataka coast, and then going up to north, that is Maravante, Kundapur and all. The stretch is around 90 kilometers. It lies between 12 degree 45 minutes to 13 degree 45 minutes north latitude, 74 degree 40 minutes to 74.55 east longitude. The total stretch or the coastline is approximately inclined in the direction of north, northwest and south, southeast direction. The total length is 120 kilometers. Maximum temperature so far recorded is 30 degrees centigrade, and that is the highest, and minimum or coolest temperature is 23 degree in the month of December. The area receives very high downpour with an average annual rainfall of 3,950 millimeter, of which 85% is during monsoon season only. Within this study area, we have identified some of the specific locations. Those locations are again classified in the form of Zone 1 to Zone 5. Zone 1 is river mouth without breakwater. The best example is Mulki Pavanji river mouth. It is around 8 kilometers from our college area. Second one is open coast. It is NATK to NMPT. This is New Mangalore Port Trust, and our college is north of this, and this is called open coast. Coast with man-made structures. Again, New Mangalore Port Trust. Now it is called New Mangalore Port Authority. They have constructed 2 breakwaters projecting into the Arabian Sea. And next to that, we have Netravati Gurupur river mouth. There also 2 breakwaters are there. These 2 comes under Zone 3. Very important zone is zone number 4. This is coast parallel to river. If you see all along the west coast of India, all the rivers are originating in the Western Ghats, flow westwards, and then take almost 90-degree bend near the coast. And this is nothing but neotectonic activities. After taking the bend around 90-degree, they will be flowing maybe to minimum of 2 kilometers to maximum of 10 kilometers, and finally joining together again minimum of 2 rivers to maximum of 5 rivers along this coast, and then discharging water as well as sediment into the Arabian Sea. Also, this zone number 4 is very important because we have the sand spit. On both sides, we have the water body. On one side, that is western side, we have the Arabian Sea. On eastern side, river. This indicates that this particular zone is always vulnerable for erosion because minimum wave activity is also more than sufficient to remove the sediment available all along this beach. The last one is river mouth with breakwater, again Netravati as well as NMPT. For this, data were used in the form of conventional as well as remote sensing data. All these data were purchased from Survey of India topo sheet or naval graphics from NMPT, and directly we also went to field visit in the form of GPS survey. Remote sensing data, it is high resolution merged data of list 3 as well as PAN, and IRS P6 data, it is from NRSC. For specific location, we also purchased Cartosat 2.5 meter resolution data sets. All these things are required to prepare base map, chain detection map, and also to finalize LULC, bathymetry, and finally incorporate all these outputs in the form of CVI or to develop CVI, Coastal Vulnerability Index. The software packages used are number 1 is ERDAS Imagine 8.7 and ArcGIS software. This is the overall methodology, both conventional remote sensing data. This is in the form of tracing and digitization, optical remote sensing data, and then identification of land features, and different maps prepared in the form of waves and tides, shore lines, bathymetry, LULC, drainage, and all these things are validated with the help of ground truth verification. Finally, data integration and analysis of thematic layers using GIS environment. And before finalizing ICZMP, we have conducted the feedback session with the help of all the stakeholders over here and then updated the information. Final information was also developed in the form of customized map and information in the name of CZIS, that is Coastal Zone Information System, by using Visual Basic 6.0. This is the actual CVI development with the help of around 7 parameters. To start with, LULC, CRZ map, road network, shoreline, drainage map, contours, that is in the form of DEM as well as bathymetry, and finally all the coastal processes, that is geographical information related to that location, that is in the form of tides, waves, winds, currents. They are also called as general oceanographic parameters. The first one is shoreline data monitoring, that is starting from 1967 up to 2006, and recent one is Cartosat. 67 to 87, you can see all along the coast, starting from Talapadi going up to Kundapur, most of the places we have identified only erosion. The red color in the legend indicates that erosion, that indicates that maximum area covered by erosion. That indicates that west coast of India or Karnataka coast during that time between 67 to 97, 87 is mainly under erosion. Some of the specific areas like Maravante beach, you can see here, this is the Kulur river and this is Arabian Sea. Only the road network is remaining. So this particular location has to be taken care, otherwise there will be a de-link between North Karnataka as well as South Canara. This is Angarakatte estuary, Udyavara river mouth. And this is Mulki Pavanji river mouth. And last one is Netravati Gurupur river mouth. And north of it we have NMPA, New Mangalore Port Authority. 87 to 2000 shoreline chain detection maps showing most of the places under deposition. The green color indicates deposition. The percentage of erosion along this coast during this time is minimized, whereas deposition is maximum. That's why maximum color is in the form of green color. These are all the zoomed version of the same location. Kulur river and then Aladi, Gangoli estuary, and we have Udyavara river mouth, and then Mulki Pavanji, and last one is again Netravati Gurupur river mouth. Third one is 2000 to 2006. It is exclusively for shoreline monitoring. Now you see most of the places again under erosion itself. This indicates that if you have the data, that too in the name of remote sensing data, it is possible for us to get the temporarily data sets every year, every 1 month also it is possible for us to analyze, and that's how it is possible for us to identify the temporal changes. Over a period of maybe 20 years itself, it is possible for us to identify lot many things. That is also in the name of dynamic equilibrium maintained by the nature. These are all the enlarged version of the same locations. Yeah. If you quantify all these in the name of erosion as well as deposition, you can see 67 to 87, most of the places are erosion. 2000 to 2006 is again erosion, whereas 87 to 2000, it is in the name of deposition. And if you take the net value, again, deposition is more than erosion along this coast. Next component is to identify the littoral drift along this coast, how exactly the coastal construction, maybe in the form of breakwater or seawall, is going to affect. This is one of the photographs collected from P.D. Komar Coastal Processes textbook. Here, this is the initial shoreline. If you construct anything in the form of, say, breakwater perpendicular to the seawall, if littoral drift is maximum or moment of sediment parallel to the coast is maximum, then there will be a deposition on one side, erosion on the other side. Also note that if you see the contours, the deposition contours are almost equal to erosion contours. This indicates that here also deposition is almost equal to erosion. Again, equilibrium is maintained. To check along this coast, we have selected New Mangalore Port Authority as a specific study. For that, you can see the two breakwaters projecting into the offshore region. These two breakwaters constructed in 3 different phases. Earlier, the length was 330 meters, afterwards 550, now 770 meters from the shoreline. And these breakwaters are mainly constructed for 3 different purposes. Number 1, we know that ships will not be having any brake. They will be controlled by the propeller only. So they will be having sufficient stopping distance while coming to the harbor area and also turning circle over here. Second one, to create tranquility condition inside the harbor area, wave activity will be minimized so that loading and unloading can be taken place nicely. And third one is, if any sediment is moving from the beach into the approach channel, this approach channel is very deep, that is 15.4 meter charted datum, and length is 7 kilometers. So if any sediment is moving, that has to be protected by these 2 breakwaters. To identify the beach slope, we also conducted sea sled survey operation. You can see the sea sled over here. This is the iron material constructed over here. And we have the 2 runners, aluminum runners. At the front, it is projected upward so that it will not go and struck in the beach itself. There is a 6-meter mast. And finally, it is having graduated rope. This was taken into the offshore region around 400 meters from the shoreline, and slowly that was dragged. When it is coming towards the beach, we have measured all the levels by using the dumpy level and other things. Now, if you invert the data sets, it is possible for us to get the seabed profile. Also, by using all the other general oceanographic parameters, by using Mike 21 software, we also developed the bathymetry like this. You can see here also all the bathymetric contours are almost parallel to each other. With respect to the local information, that is nearer to the breakwater itself, lead line survey data was collected from NMPT, Marine Division Wing, and then we have plotted the information like this. Now, over a period of 72 to 77, that is during the construction of the breakwaters, or 71 to 2000 after construction of all the 3 phases, most of the contours are parallel to each other on northern side as well as southern side. This indicates that there is no deposition on one side or erosion on the other side. This also indicates that there is a offshore onshore sediment transport. There is no or minimum sediment transport along the beach along this particular coast. To justify this, we also use naval hydrographic charts, NHC. All these things will be in the form of point data sets. These point data sets were digitized and then created the map like this. Sorry. After plotting the bathymetry, again, with the help of naval hydrographic charts as well as GIS analysis, you can see the contours are again parallel to each other on either side. And this is the approach channel as well as the harbor area. This also confirms that these 2 breakwater constructed at NMPT are working satisfactorily without indulging in coastal erosion or deposition processes. But immediately after the southwest monsoon or beginning of the southwest monsoon, NMPT is facing problem related to sedimentation. Maybe between first day to around 20th day itself, most of the area that is approach channel will be sedimented or silted immediately. Then we have conducted another study where exactly this particular sediment is coming from. We have taken the samples along the beach as well as perpendicular to the beach, going up to 7 kilometers over here. That is in the form of N1 to N7 northern side, S0 to S7 on the southern side. After the analysis, we came to know that only pure sand is there on the beach, whereas silt and clay in the Arabian Sea related to bathymetry like 5 meter, -5 meter, -10 meters, etc. Whatever the sediment available inside the approach channel as well as the lagoon area is only silt and clay and not the pure sand. Based on this, we have identified and concluded that this is only the silt and clay coming from the offshore region, mainly during the southwest monsoon. Because of the turbulence, bottom sediments will become into suspension. Because of this depth, 15.4 meter charted datum, most of the sediments will be deposited over here and local currents will be pushing the same thing into the harbor area or the lagoon area. So based on this, critical erosion areas were identified. This is by remote sensing data sets. And to finalize the remote sensing data, definitely we have to go to field visit with the help of GPS as well as geocoded product to get the actual information. This is GPS analysis and come back to the field from the field, and then in the laboratory within no time we can develop this particular map. This indicates that field validation GPS data is available, actual conventional data analysis is also available. Compare both of them, that is in the form of estimated as well as actual erosion accretion field data sets. Definitely it is possible for us to identify actual erosion area as well as actual deposition area. This is our one map in the form of zoomed version. Finally, area-wise estimation 1967 to 87 minus 5.33 kilometer square area, that is beach sediment, whereas 87 to 2000 14.85, this is in the form of deposition. If you take the net value, still deposition is more than erosion. Coastal regulation zone maps, CRZ maps. Based on this data and also by using the CRZ, in India we have CRZ information starting from 1992. It is in existence. Based on that, CRZ 1 is 0 to 100 meter from HTL and 0 to 200 meter and 0 to 500 meters, CRZ 1, 2, 3. Those maps were prepared directly. After preparing with the help of these are all the zoomed version. After identifying all these things, we have identified the local information, that too in the form of specific land use, land cover changes. Maybe by taking 20 kilometers away from the shoreline, and that is the width covered over here, exclusively nearer to the river mouth or the specific locations such as Kollur River with respect to the Arabian Sea over here, that is Marvante Beach. After identifying all these things, LULC, then we've thought that it is better to go for inundation map also. Once we have the inundation map with respect to LULC map, it is also possible for us to identify which particular or which specific information is going to be submerged or the parameter is going to be submerged, that can be identified easily. This is the contour maps. And then on the contour maps, remote sensing data was also draped like this. And two different dates of the data can be compared within no time. And then preparation of inundation map. So this one, like if you give 1 meter sea level rise, how much area is going to be submerged along the coast? That is number one. Number two, what are the LULC features going to be submerged? Number two. Number three, within CRZ 1, 2, 3, what type of features are going to be submerged? Those information can be calculated within no time. This is 1 meter. This is for 5 meters. You can see water spread area is maximum. And this is for 3 and 4 meters in between. The last one is for 10 meter resolution or 10 meter rise of SLR, that is sea level rise. So now if you see the area, if it is 1 meter rise, only 50 square kilometer is going to be submerged Whereas if it is 10-meter rise, it is 370, around 70 square kilometer. This 10-meter is taken in the form of 2004 tsunami, that is 34 feet, feet, that indicates around 10 meters. We have restricted our analysis. Also note that all along the west coast of India, we cannot expect 10-meter rise. It is only for the analysis. Maybe we can start off with the 1 meter or 0.5 meter nowadays, because we have got very good high resolution data available from remote sensing data sets. These are all the area estimation. Finally, to incorporate in CVI map or the index map, we also generated coastal geomorphology maps. With this, range of values for different variables have given, that is in the form of ranking. If you select the first one, that is geomorphology, number 1 represents very low ranking, very high is number 5. We know that rocky cliff coast is not going to erode easily, whereas coastal plain, beach, mud flats are going to be eroded immediately. So that is why the rank is number 5. So based on this ranking, now we have identified lot many places for erosion as well as deposition. After ranking, this particular maps are called as coastal vulnerability index maps. So based on this, action map or action development map was also developed. So within this, we have the coastline, river information, port facilities, tourism, coastal regulation, violation spots, as well as CRZ 1, 2, 3 are also available. In addition to this, what are the places which are available for further development? Such places were also identified. And other than that, depending on the wave concentration or where exactly waves are directly acting on the beach, such type of locations were also identified, and those data sites should not be used for any or further developmental activities. So this is the final map for undivided Dakshina Kannada coast. So these type of maps were given to decision-taking people and also submitted to Ministry of Environment and Forest officers. These are all the zoomed version. After developing all these things, we also identify some of the locations where water is stagnated, that is in the form of wetlands. So we have also analyzed in the form of wetland monitoring as well as management. This is the area, Pavanjai river mouth area, that is slightly north of our college area, that was analyzed. And to identify the pore pressure along the beach as well as nearer to the beach, after visiting USC, University of South Carolina, we have identified lot many things we can also do in our course. After that particular knowledge, I came back from USC and then started developing a model for our own course. And this is one such example for Woolard Beach. Woolard is, you can see, sometimes the width of the beach is minimum, maybe 50 meters or less than 50 meters. This is the Netravati river, northeast we have the Gurupu river. So here, lot many dwelling houses are there, fish processing industries. We have to protect them. For this, the actual situation is like this. Sea wall constructed almost nearer to the dwelling houses only. So here we have selected some of the borewell as well as open well locations, and we have also identified the location to collect soil moisture information. And based on that, it was identified that variation of hydraulic gradient, that too with respect to the observation wells, groundwater observation wells over here. Towards northern side, we have selected another area, that is Udupi district. Here, 7 locations were selected. Out of that, with the help of data set, that is groundwater level collected from Central Groundwater Board, CGW, and also India Meteorological Department. From that, all the parameters in the form of rainfall, temperature, relative humidity were collected, and then analyze the data just to get the information about temporal variation of groundwater level. Here the analysis starts from 1996 going up to 2020. And also seasons like winter, pre-monsoon, monsoon, as well as post-monsoon. If you see the year-wise, that is 1996 versus 2020, and also the index over here, the water level fluctuation can be identified. So here, during the winter 1996, it was between 7 to 9 meters, whereas here it is between 6 to 7 meters like that. That indicates that fluctuation groundwater is can be identified, and also level is increasing. On the other hand, if you take during the post-monsoon season, that is 96 as well as 2020, the green color indicates that it is between 6 to 7.9 meters most of the area, and now in most of the area it is reduced to 4 to 6 meters. That indicates that groundwater fluctuation is minimum, is available, but level is increasing. So all this information, next to that another one is Kundapur. Kundapur area, we have got lot many aquaculture ponds, and there also the water level will be fluctuating minimum, that is because mainly because of the water already available near to the surface itself. So all these things were finally incorporated and developed ICZMP map for Dakshina Kannada coast. After developing this, we have also generated a database in the form of Visual Basic 6.6, and this is the customized information for the software, that is Coastal Zone Information System. And if you click on any one of these data sets, it is possible for us to get the information directly. This is for shoreline, and this is for other thematic map information like transportation map, digital network, or GIS based maps, etc. With all these things, we have to remember what exactly we have to do at the time of shoreline management, monitoring, etc. That too in the name of ICZMP. There are 7 golden rules available. Number 1, understand the natural beach system before it is altered. Site-specific studies may be required at many localities to ensure wise planning and decision. Develop a setback line before construction begins. It is also in the form of HTL identification. Where a major obstructor to longshore sand transport is built, such as large harbor, allow for an adequate sand bypassing system. Wherever possible, use soft solutions such as sand nourishment, diversion of channels, rather than hard solutions such as revetment, seawalls to solve beach erosion problems. Maintain a prominent fore-dune ridge. If a beach is vulnerable for tourism, recreation, or wildlife habitat, do not mine the sand, that too from fore-dune, beach, or near shore. Do not panic after a storm and drastically alter the beach. Wherever possible, let the normal cycle return the sand. So this is what is happening all along the west coast of India. Most of the time, mainly during the southwest monsoon, sediment will be taken into the offshore region, and slowly during the non-monsoon season or fair weather season, same sediment will be coming back to the beach. In conclusion, around 46 kilometers of total 90 kilometer stretch of study area is under critical erosion. 42.19 square kilometer will be submerged for 1 meter sea level rise. CVI can be utilized to identify areas where physical changes are most likely to occur as sea level rises. For planning, tool for managing and protecting coastal processes. Identification of critical erosion area will assist in monitoring the developmental activities along the coast and also provide necessary safety measures for the existing settlements. Various thematic and derived maps can be integrated to acquire necessary information in order to make suitable decision for the sustainable development of the area. CZIS, that is Coastal Zone Information System. This module provides dynamic interface for selected parameters such as coastal land use, land cover, ocean parameters, shoreline change, etc. and does help in sustainable development of the coastal region. These few words. Thank you so much for your patient hearing. Thank you, sir.
Thank you, sir, for your informative talk regarding coastal management, coastal zone management plans. Sir, I have one question to you.
Please, sir.
Do you have any collaboration with the government agencies? Because you publish a lot of work, how to manage the coastal zones. Do you have any collaborative works, any success stories after your intervention, after the publication, any activities taken by the government departments?
Yes, sir. We do have the collaboration with the government, state government as well as central government also. I am one of the 4 panelists available for identification as well as formulating the projects under ADB in the name of National Coastal Zone Management Authority. And our department is doing lot many works for Karnataka coast also. And most of our works are related to New Mangalore port areas.
Thank you, sir.
Thank
you, sir. Any questions from the audience? Please. Here is madam is ready.
It was a very nice presentation. It was very in-depth, giving us a lot of information along the coastal zone. I just wanted to ask one question, sir. One of your slide, you have taken some data over a period of time. For 2 successive periods, we have find there were deposition. In one, we have find accretion. What can be the reason that in a particular year we have got accretion and for the other 2 years there is deposition or erosion? How can you justify or answer to that? Like, is there a particular phenomena that has affected that?
Hello.
Please. Please.
Madam is asking that in one at different timings have taken the remote sensing photographs. In one period there is a what I can say erosion was not there. Another period erosion starts. What's the reason for that? She's asking. Madam is asking.
This is like a natural phenomenon itself, sir. For example, if you are leaving the beach just like that without venturing into that, nothing is going to happen. All the beaches are considered to be the nature's playground or waves playground. After venturing to that, definitely we have to face the consequences. That indicates that the nature is already maintaining the development or in the form of dynamic equilibrium. We should not disturb that. That is identified by remote sensing dataset directly. Cyclic nature of erosion as well as deposition.
Thank you, sir. From students. You can speak loudly.
Erosion is more than the deposition in coastal areas. It is processed often also for saline water intrusion. So, what will be the coastal zone management strategy for that, sir?
Have you got it, sir? Question?
Please repeat, sir.
If the erosion is more than the deposition,
yes,
then saline water enter into that area. How to manage that?
Erosion is more than
deposition.
Yes, sir. That indicates again the wave concentration, sir. During that time, we have got the concept of wave divergence as well as wave convergence. Wherever the locations which are having wave convergence, that location is always vulnerable for erosion. We should not go for any developmental activities nearer to that particular location. On the other hand, we have the wave divergence. Wherever wave divergence is taking place, we have the very good beach undisturbed by the waves also. That particular location can be considered as the further developmental activities locations.
Thank you, sir.
How to prevent? That is, there are so many methods available, both in the form of arts as well as soft options. Hard options include construction of seawall, breakwater, jetties, revetments, etc. Soft options, that is in the form of growing vegetation, mangroves, and also sand bypassing.
Thank you, sir. Any questions from the audience? If no questions, I thank once again Dwarakish sir for his elaborate and informative talk. Now,
Thank you so much.
for-
Thank you,
sir.
sir.
Thank you, sir.
Thank you, sir.
Thank you very much, sir. On behalf of KST and on behalf of all the participants, I would like to thank Dr. C.S. Dwarakish, sir, for
Thank you so much.
presenting today's session, sir. Thank you very much, sir. Also, I would like to thank Dr. Ramakrishna Reddy, sir, for chairing this session. On behalf of KST and on behalf of all the participants, thank you very much, sir. Now, I request Dr. Srinivas Vittalji to hand over a moment to Dr. Ramakrishna Reddy, sir, as a token of respect. Thank you, sir. Now we'll be having a lunch break. After that, 2:30 there will be a session. You can join at 2:30. Thank you. Thank you very much. Sir, are you there, sir?
Yeah. Thank you so much.
Thank you so much, sir.
Thank you. Bye bye.
Glad to see you, sir. Thank you, sir. Thank you, sir. I'll speak
I
to
am
you.
very
evening,
happy
sir.
to see you.
Thank you, sir. Thank you.
First batch RSGS, right?
Yes, sir. Yes, sir.
Bye. Take care.
Bye. Bye. Thank you, sir. Thank you, sir. Bye.